I believe that practice makes progress. We are now going to evaluate our progress from what we studied in lesson 1 and lesson 2 by doing question 1. In the Scienceless channel, when solving problems, we apply what we call the academic constitution. These are rules that we follow when we solve problems. We have 4 rules. The first rule is the I rule. The second rule is the C rule. The third rule is the A rule. And the fourth and last rule is the N rule. These rules, they spell out I can. This means that if you follow these rules, you can solve any problem. We are going to start with the first rule, the I rule. The I stands for interpretation. We interpret our problem. To interpret our problem, we firstly read the given problem, choose the direction, write down the given information, draw pictures or diagrams in order for us to visualize the problem because it is a physical problem, and draw vectors where it is necessary. I'm going to start applying that rule. The question reads as follows. A ball of mass 2 kg moves on a straight road at 4 meters per second to the right. The velocity of the ball decreases to 2 meters per second due to frictional force. Now I am going to draw a diagram so that I can put all this information that I'm given on a diagram. It is clear to me that we have a straight road that has a ball with a mass m is equals to 2 kg, and it starts moving with an initial velocity of 4 meters per second, and it is going to the right. That actually reminds me to choose my direction, to say anything that goes to the right is positive and anything that goes up is positive. This implies that if anything were to go in this direction, it will be negative to the left. The ball moves towards this direction such that at some point here, when it arrives here, it will then now have the final velocity, which has decreased to 2 meters per second. This means that this object is actually slowing down because we have a vector that is smaller than the vector that we started with, 4 versus 2 meters per second. That is all I can do in terms of interpreting this problem. So in terms of our problem interpretation, we are done. Now we move to the second rule that says C. The C stands for classification of the problem. What this rule requires us to do is to actually link the given problem to the theory, formulae, concepts, and the laws or principles that we have studied in physics. So when I look at this problem and read this problem, I think it's a problem that links with momentum and change in momentum. The reason I say that is because I can see that I'm given the mass and I have velocity, which will somehow translate to initial momentum. And I have the final velocity, which can translate to the final momentum. And because I have the final momentum and initial momentum, I can somehow speak about change in momentum. So I might be required in this problem to do calculations that involve momentum and change in momentum, and even be asked to define momentum or change in momentum. That is how you classify a problem. You try to see what topic does it link with before you begin doing the problem. We are now done with classification. This will assist me not to run around trying to just pick any formula on the formula sheet when solving this problem. I am now specific. I know where to go when I want to solve this problem. The third rule is the A. The A it stands for problem answer. It means that we are now ready to go answer our problem. We have a broader understanding of this problem. That means I'll jump straight to question 1.1. It says that define the term momentum. Already I'm smiling because I expected to get a question like that. Momentum can be defined as the product of mass and velocity of a moving object. As far as question 1.1, we are done with answering it. The last rule then is the N rule. N stands for navigation, problem navigation. This rule means that we check for errors in our answers to see if our answer makes sense. So this means that you will go back and look at your statement and see if you didn't make any spelling mistakes, grammatic errors, and if your statement makes sense. My statement makes sense because when I'm reading it, it's sitting properly. Now you have to note that we have now applied all the rules for question 1.1. To go to question 1.2, it means we'll go back to problem answer because already we interpreted and classified it. We still have the same interpretation and classification. So it means we'll jump to answer again so that we can answer 1.2. And in fact, when we go to 1.2, the question reads as follows. Calculate the initial momentum of the ball. We are required in 1.2 to calculate the initial momentum of the ball. And again, during our problem classification, we expected to get a question of that nature. Now, in this case, I'll say my initial momentum is equals to the mass times the initial velocity from the definition of momentum. Now, we know that our mass is 2 kilogram and our initial velocity is given by 4 meters per second. And it's going to the right, it's a positive direction. So this means I'm going to be left with an answer of 8 kilogram meters per second, which is going to be positive. And when it's positive, it means that it goes to the right, because anything that goes to the right should be positive. Because we have answered this problem, we are now going to navigate this problem. We go to our fourth rule again. We check if this answer makes sense. So this answer, I feel comfortable with it because it's not extremely big for a ball. You know, we're speaking about a ball in this problem. I'm not expecting a big momentum. And the SI units are there. Also, my direction makes sense because my velocity is going to the right. I expect my momentum to also go to the right. But you have to notice here when I'm navigating this problem that I forgot to put the I here. Then I rectify that. That's the error that I spotted as far as problem navigation. Then now everything looks okay and it makes sense. Then this means we are now ready to go back to problem answer so that we can answer the next question, which is 1.3. But before we go there, let us talk a little bit about how these problems are going to be marked. Remember that the marking system uses the convention that you spend 1 minute for 1 mark. So here it's 2 marks. It means you must spend 2 minutes to write that answer. And I think most of you will agree with me that if you have studied, you would spend less than 2 minutes in this problem. So that means this type of problems, if you get them where you write a simple statement like this, that's where you buy time, because you can literally write this answer within seconds, allowing you to have more time to answer other questions that can be difficult in the exam question paper. Or not even difficult, but require more time from you. The 1.2 problem will be marked as follows. You'll get 1 mark for the formula, 1 mark for the correct substitution, and 1 mark for the correct final answer. Now the final answer will look at everything, your symbol here, your number and SI units here, and the direction. All this is 1 mark. If any of these have problems, you will lose that mark, you'll be marked wrong. Hence, it is important to apply the fourth rule, navigation. Check if your answer is okay and it makes sense. There is no errors. Question 1.3. says calculate the final momentum of the ball. We are required to calculate the final momentum of the ball. To do this problem, I'm going to use our formula as per the definition. PF is equals to mvf. And we know that the mass is 2 kilogram and our velocity is 2 meters per second. So this means I'm going to get a final answer of 4 kilogram meters per second. So this means our final momentum is going to be 4 kilogram meters per second to the right, because it is a positive answer. In fact, let's navigate this problem and see if it makes sense and it doesn't have errors. Our answer is positive. That means it goes to the right. And when we look at our velocity, it also goes to the right. Remember that velocity and momentum are directly proportional, meaning they'll go to the same direction in as much as they increase and decrease with the same ratio. And also when I look at my number, it's not a ridiculously small number or big number for a situation where we're dealing with a ball. So I'm comfortable with that answer and everything else looks okay. So I'm done with the fourth rule of navigating this problem. Now again, this question will be 3 marks. It will be marked in the same way they marked question 1.2. So 1 mark for the formula, which is in the formula sheet. It's a free 1 mark. 1 mark for substitution and 1 mark for your final answer. The last question says, calculate the change in momentum of the ball. We are required to calculate the change in momentum of the ball. Now, there are various formulas that we spoke about when we defined change in momentum. I'm going to use the first one where we say change in momentum is the same as the final momentum minus the initial momentum. It's the difference between the final and initial momentum. The reason why I choose this formula is because already I can see that I've calculated my final momentum and calculated my initial momentum. So I'm just going to take these two and substitute them here on the formula. It is also correct to use the other formulas to give you the correct answer. In fact, you can try them. Now, in this case, we are going to have a final momentum of 4, and then there's minus an initial momentum of 8. And this will give me an answer of -4, because 8 is half of 4 kilogram meters per second. Now, because we got a negative answer, it means our momentum, our change in momentum, is actually going towards the negative direction, which is the left. So that means here I'm going to write my final answer as 4 kilogram meters per second to the right. The negative here implies direction, just like the positive was implying direction. It does not necessarily mean this answer is a small negative integer. It means that it is going to the left. Now let's do problem navigation to see if our answer makes sense. I can see that I've written the delta P correctly. My answer is looking okay. It's a 4. Very reasonable, not so much big or small for a ball again. But notice that here I've written to the right to mean to the left. So it's a mistake that I need to rectify. Remember, when you navigate, you are actually checking for errors. So this means here I spotted the error that negative means left, not right. And I've done a mistake of writing the word right there. Now my answer looks absolutely correct. But does it make sense to say the change in momentum is actually going to the left? Well, it does, because if you check this problem, we can see that the object is actually slowing down. We start off moving fast and we decrease our velocity because they said here that there is a frictional force. So obviously friction will oppose the motion of the object and it will make it to start moving slow. Eventually this object, when it gets here, it will have a velocity of 0. So it makes sense because we know that for an object that is slowing down, the change in momentum vector will be in the opposite direction as the velocity vectors. To understand what I mean by that, please make sure that you go to lesson 2. We discuss this thoroughly under the vector nature of change in momentum. So my answer looks correct. It makes sense. Now, this question will also be marked for 3 marks. They'll mark the formula, they'll mark the substitution, and the final answer.